appreciate the importance of from your vocabulary and stuff. Does anybody have any idea what the heck redox is used for? Rachel?
Creating a pure metal atom?
It can, yes. It is used to purify metals, which is why it's actually in this part of our study, correct? We're talking about building coins. We get these minerals out of the ground because metals are very reactive, so we need to find a way to purify them. More importantly, Abby Lane over there filming is using a portable device. And what is that portable device using for power? Batteries. So redox chemistry is the fundamental basis of all batteries, which imagine if batteries disappeared. What would your life be like? Oh my God, you'd be back to when I was a kid. Oh no. But cars have batteries, you know, your little, remember those big huge E-cell batteries that people used to put in your toys when you were little at Christmas time or Hanukkah or whatever holiday you celebrate? Yes? So batteries are based on redox. At one terminal, we're donating electrons. At the next terminal, we are accepting electrons. So redox chemistry is fundamentally based on electron transfers. Now, there's an acronym that the Brightstorm people provided for you. Some people love them, those mnemonic things. Other people hate them. I think this case, there's some tricky terminology here, so this oil rig is very useful. Does anyone remember from your notes or from your reading what oil rig means? Mr. Creasy.
An oxidation is loss.
Yes. Oxidation is loss of what? What are we talking about?
Electrons.
Electrons. So what's the other one here? If it's not oxidation, it's
Reduction.
reduction is what?
Gaining.
Is a gain of electrons. So where students have some mess ups in their head is let's separate these two processes. First of all, do they ever occur independently?
No.
Because why? Yeah, I can't have electrons just flying around, right? In the space of chemistry, somebody has to catch this. If somebody's throwing it, somebody's catching it. And when we get rid of an electron, what kind of ion do we become? Positive, and the fancy name for that is? And when I accept the electron, I become an anion. So oxidation and reduction must occur together. And that's how the whole battery thing works. So oil rig tells me oxidation is a loss of electrons, right? So reduction is a gain. Now here's where it gets discombobulated in students' heads. The charge on the atom or the ion is going to change when it gains or loses electrons. And Rachel reminded us we can use this to purify metals. And when I have a pure metal in my hand, what's its charge? Its oxidation number is zero. So when a metal has a charge on it, we know that it is an ion, but how it must does it exist by itself? No, it's in a couple. So when this guy loses an electron, I'm going to use the word joins because it matches with my prom analogy. Joins a compound, right? Do we agree? Now over here, when this guy gains the electrons, what does he do?
Leaves the compound?
Leaves the couple. He becomes a solo pure element. So I'm not using the most perfect terminology here, but I'm trying to anticipate some issues with understanding the vocabulary. So don't go telling your college organic chemistry professors that we have couples and stuff. They'll probably go, who taught you? Anyway, so we join a compound if we're oxidizing because I am giving electrons to someone else. When I accept those electrons, I then stand alone and I become pure. So this is where it gets a little funky, is that my overall charge, what happens when I lose electrons? My charge goes which way? Up. And now when I gain electrons, what happens to my charge?
Goes down.
Goes down. And this is where kind of people are like, well, wait a minute, if you're gaining something, how can your charge be going down? Because you're gaining a negative. Electrons are negatively charged. So this essentially, for our purposes, is the basics of redox chemistry. Now, we saw in the videos that there are two basic ways to write this information down. We can see it in the reactions that we did in our little, let me actually write one of the examples that we did. We took magnesium metal, so its charge would be Magnesium metal, its charge would be
0.
0. And we added it to our nitrate solutions, right? So let's say we added it to our silver nitrate. And did we see a reaction?
Yeah.
Because, which is the more active metal? Magnesium says, I want your date, get the heck out of here. So they switch, and we end up with pure silver that looked like that furry fungus stuff, and magnesium nitrate. And the equation's not balanced, I get that, don't worry about it. So what happened here? Which one was oxidized and which one was reduced? Scientists have found a way to write just the players here. Unfortunately, in my analogy, girls, we don't care about you. So we're going to write magnesium metal combines with a silver ion to form silver metal and a magnesium ion. So the implication is that these guys are in an aqueous solution. Oops, we can't have two ions. What am I doing? There we go. And this guy would be a solid. This guy would be our pure metal. This guy is in solution. We also can write it just the specific individual metals. So I could also write this as magnesium turns into a magnesium ion, plus he's given those 2 extra electrons to somebody. And we could write the opposite for the silver, correct? The silver starts out in a couple, plus his electron, and then he ends up as a pure element. So you may be asking, why the heck are there so many different ways to write this? So this is called the half reaction. This is the chemical equation that we have to deal with not being balanced. And here is the more common form that we see redox written in our textbook. They're all saying the same thing. Convince yourself of that, right? Ions can't exist by themselves. This implies that this guy's in a couple. We just don't write the girl here because we don't really care about her. We're interested in what's going on with the metal. So back to my initial question, who's being oxidized and who's being reduced in this equation? So the oxidizing, the thing that is oxidized, loses electrons, joins a compound, charge goes up. Do you know who that is? And Alexa says magnesium. You want to explain that for me?
Because it lost an electron, so it became a cat. Cat ion, and it bonded with the.
Yeah. So let's see. Magnesium starts out like this, and then what happens to him? He coughs up these 2 electrons, and he finds a girlfriend. Silver, on the other hand, what happens to it? Its charge goes from +1 to 0. So its charge went down. Charge goes down. I'm reduced. Also, another way to think of reduced is I become pure. In the end of this equation, who's left as a pure metal?
Silver.
Silver. So silver was reduced. Its charge went down. It got rid of the couple. You can